Okay, so the way I want you to do these problems is to fill out the table first and then use the information in the table to answer the other questions. All right, so let's start with the table. All right, we have a function f from the even integers to the odd integers. F of x equals x plus 1. That's the rule. All right, so we'll start by filling out the table. -4 plus 1, -3, -2 plus 1, -1, we got 1. 2 plus 1 is 3, 4 plus 1 is 5. 6 plus 1, that is a 6. Yes, 6 plus 1 is 7. All right, now one thing that absolutely must be true, that you absolutely must have with these tables for the reasoning that I'm going to explain right now to work, is that we have to have this unique part. All right, every entry in the first column must be unique, or else everything that I'm going to say right now breaks down. And by unique, I mean different. So everything in the first column has to be different. If that's the case, then what I'm going to say now will work for you when you're doing these problems. Okay, so, all right. And most of the time it will be unique, but you should just check real fast when you go to do these problems. Just make sure your first column, everything is different. Okay. All right, so now that we have the table filled out, we can tell whether or not f is a bijection. All right, remember, what does it mean to be a bijection? F is a bijection if and only if, that's what this double arrow here I have written here means. If and only if, otherwise known as, means the same as. These are or equivalent. These are equivalent ideas. So f is a bijection if and only if, or means the same as, f is 1 to 1 and f is onto. So a function is a bijection if and only if it is 1 to 1 and onto. Okay, so let's first discuss how you see from the table if a function is 1 to 1 or not. Okay, so we're going to look at 1 to 1. Okay, remember that a function is not 1 to 1 if we have this situation. Okay, so if a function has this situation where you have two different inputs go to the same output, then it's not 1 to 1. And that's really what all I want you to get, all I want you to remember about 1 to 1 is that really, if it's not 1 to 1, what that I want you to be able to draw this picture, okay? To remember what not 1 to 1 means. Not 1 to 1 means that you have two inputs that go to the same output. Okay, so this, from the table, we can see that f is in fact 1 to 1. We have, because each of the entries in the first column is unique, and everything in the second column is also unique or different, we see that we don't have this situation where two inputs go to the same output. Now let me show you what would happen, right? Let's say that we replaced, let me show you what would happen to make it not 1 to 1. Let's say we replaced -1 with -3. Right, this would still be a function, but it wouldn't be 1 to 1. So if we had that, then we'd have -4 here, -2 there, and -3 there. So there we'd have two inputs, namely -4 and -2, going to the same output, -3. Right, this, and what I'm saying here is this is if I was to replace this -1 here, this -1 right there with -3. Now I'm not going to do that because that's not what makes sense for this function. This function doesn't have that property. But that's how a table would look where it was not one-to-one. Would be that you had repeated values in the output column. Okay, now let's move on to onto. Onto, remember, it means that everything in the target gets hit. Okay, our target is the odd integers. So we ask ourselves, do all the odd integers get hit by this function? And in fact, they do. Now, to know for sure if this function is odd, we would have to prove it. But I'm not going to have people in this class prove one-to-one and onto. That's beyond the scope of the class. For the math majors, you'll see that in Math 287. I'm pretty sure you'll have to do that there. The basic idea is for how you would prove it, right, is that if you, here we have the odds, here we have the evens. So what does a general odd look like? It's 2n plus 1, right? So what's the even that comes over to 2n plus 1? You guessed it, 2n. All right, so, but we can see that, but just intuitively from the table, we can think to ourselves, okay, what if I picked another odd that's not in the table? Let's say 101. What's the one that would come over to it? Oh, that's 100, right? Because 100 plus 1 is 101. Okay, I can see that it's onto. Okay, since it's onto, since it's both a one-to-one and onto, it is a bijection, so I fill out that. Okay, now remember from the Xi book that F inverse, the inverse is a function if and only if F is a bijection. So if you fill out F as a bijection here, then you have to, and you understand the relationship here, then you know immediately that F inverse is a function. If you were to fill out F is not a bijection, then you should also fill out F inverse is not a function. Now remember, F inverse is just going the opposite direction. So F inverse, so if we have evens to odds, F inverse goes the opposite direction. And so the inputs to the, right, so F goes that way, F inverse goes that way. So the inputs to F inverse are now the odds, and what are the outputs? The evens.